Hello everyone and welcome back to my channel. In this video we are going to study about the scope in Python, that is the LEGB rule, that is the local, enclosing, global and built-in rule. That is, we are going to study in detail what is local and global variables, right? So without wasting any time, let us move to our Visual Studio Code. So first of all, what we are going to study in this video is something about scope. So scope in any programming language determines the visibility of a variable within the code. The scope of a name or a variable depends on the place in your code where you create that variable. The Python scope concept is generally presented using a rule which is known as LEGB rule, right? So here let me just use the acronym LEGB stands for local, enclosing, global and built-in, right? So the first thing is global variables, right? So here we are going to see how we can actually create a global variable, right? So the names or the variable that you define in this scope are available to all of your code. For example, if I declare a variable say x and in that I write a string called global, right? And if I print it simply on your screen, you can get that x is printed, right? That means it is inside this this current scope, right? You can access the value of x. Now if I make a function over here, let us say func, the name of my function, and inside function, if I print the value of x, right? And in order to execute this print statement, because it is inside a function, I need to call the function. So if I call this function and run my code, you can see that global is still printed on your screen. That means this x, which is a global variable which is declared outside any function or outside any class in your program, is accessible even inside that particular function, right? So that is something about the global variable. What are local variables then, right? So first of all, let me just comment this particular print statement over here and let me declare another variable, let's say y, and inside y I will be using a string which is known as local, right? So y is something which is having a string called local inside it. And remember that I have declared y inside my function, right? So now if I write a print statement inside my function, just pay attention that this print statement is inside my function. And if I call it, you can see that local is printed very well on your screen. But what if I comment this the print statement and call this function? This function is going to do nothing because it do not have any print statement right now. It is only assigning a value local to y variable, right? And if I call print y outside my function, right? And if I run this code, is you get an error which is a name error which says name y is not defined, right? Because the scope of y variable is only inside the function, right? That is why it is known as a local variable, because it has the scope that is visible within that particular function. So the scope is inside that function only. You cannot access it outside the function, right? So that was a little bit something about the differentiation between the local variables and the global variables. Now let me just uncomment these two print statements, right? And if I now run this code, and we will also be actually removing this, and let me just clear the screen. And if I now run this particular code, you can see that local and global, both the values have actually been printed on your screen. Now, the next question arises, what if the name of the local variable and the global variable is same, right? What if I do this as x, right? And I have to remove this y because y doesn't exist now, and this is my function. So what I did, I declared a global variable which is x outside the function, and I have declared a local variable x which is inside the function, right? And let me just print the value of x, and you can see that because this print statement is inside this function, the value which is printed on your screen is just local, right? And if I write a print statement outside this function, right, and if I run the code, then you can see that this value is going to print global on the screen, that is because it is outside the function, and this print statement is going to give you local. So now this is something when the name of your variable, the local variable and the global variable are same, right? Now, what if I want to modify the value, right? I want to modify the value of this global variable inside this function, right? What if I want to modify, just pay attention to what I'm saying. What if I want to modify this value, right, inside this function? Or not even modifying, what if I want to print this global from this function, right? See, I'm printing global outside the function, right? The inner print statement is printing local, but I want that this inner print statement should also print global, right? So how can we access the global variable inside a function, right? Because they are having the same name, right? So if I write over here as global x, right? So that is a keyword over here which is global, and what it does, it tells the function that you are reassigning this local name to this global variable, right? So now this x will be the global variable, and in place of global the value will be assigned to it local. So this time when I run the code, I should get local 2 times, right? Once is because I'm printing x over here and now x is local, and another I am printing x over here which has been now modified because of this global keyword inside the function, right? So now let me just clear my screen and run the code, and you can see that this time 2 times local is been printed on your screen. What it means is that by the global keyword, what I am actually able to do is to modify the value of my global variable inside that function, right? So that is something related with scope, right? So that is on your screen, which is the LEGB rule. It says that the local variables get the preferences, right? After that, the enclosing, we are going to study enclosing also, but till now we have seen the local and the global variables. The enclosing gets the preference, then the global, and then afterwards the built-in, right? So here you need to understand that if this particular x variable is not available over here, right, then if we print the statement, then each and every x is actually printing the global variable, right? Because you are not finding x in the local scope. So when we call this function, the control goes to this definition, right? And even if I remove this global keyword also and run the code, you can see global printing 2 times, right? So when in the control goes to this function and this print statement tries to find x, we will be searching x inside this function, right, in the local scope. But here we are not finding any x, so we move towards the outer of this function and find out that is there any global variable whose name is x, right? So here we found one. That is why both the print statement is actually printing global over here. So how it is evaluated? First the local scope, then the enclosing. Enclosing is not in this particular example. So after local, we went on seeing the globals. That is the, the process of actually inspecting the code, you can say. Now, the next thing which we are going to study is something about, let's say, enclosing. Right. So this was something about the local and the global variable, and now we are going to see something about enclosing. So let me just clear it and make the heading as enclosing. Now, what do we really understand by the enclosing scope? Now, this scope is also known as non-local. Right? So this is also known as non-local. Now, this enclosing or non-local scope is a special kind of a scope that only exists for nested functions, right? So this is applicable only when there is nesting of functions, and we have seen that functions can be nested properly, right? So there is no issues in nesting the functions. Function can be nested. Now, if the local scope is an inner or the nested function, then the enclosing scope is the scope of the outer or the enclosing function. Now, let us understand this with the help of a program. So what I'm going to do over here is I will be creating a function with the name outer. This is my outer function, or right? This is my outer function. And inside this outer function, I will be declaring a variable which will be having a name, let's say outer, right? And then again I will be defining another function which is the nested function, right? And the name of that function, because this is the inner function, the name of that function is inner. And in that, what I will be doing, I will be declaring another variable with the same name, let's say x, and I will be writing its value as inner, right? And now what I'm going to do, inside this inner, I will be printing the value of x, right? And outside, in the outer function, coming out of the inner function, please pay attention to the indentation. Here I will be calling the function that is inner, and I will be printing the value of x, right? Print x, sorry, it is x, right? And in order to execute these functions, I will be calling the outer function in the main program, right here. So let us just run the code and see what we have coded over here. Now, if I run the code on your screen, I got the answer as inner and outer. Now let us see how this works. When on the line number 12, outer is called, the control goes to this definition, right? And we find out that, okay, outer is assigned to x. Very fine. After that, there is a definition of inner function, and I know inner is assigned to x, but inner is not yet called, right? And print x. So we are not going inside this definition of inner. We know that outer is assigned to x, and okay, there is a definition. So we will be skipping from line 6 to 8. And then in the outer function, we have called the inner function. Now, when this inner function is called, the control goes back to line number 6. And here we said that, okay, inner is assigned to this variable and print x. So here you got your first output, that is inner printed on your screen, right? After that, because the definition of inner get completed, so after that we have print x, and this print x is in the outside function or in the outer function. So I got with this particular print statement outer printed on my screen, right? So that was the explanation of this particular code. Now, where is the concept of enclosing, right? So inner is enclosed inside outer function, right? So outer is the canopy and inner is inside it, right? So inner is enclosed in outer. This thing you need to understand. Now there is a difference. Suppose if I comment this particular statement, now there is no value assigned to x inside the inner function, right? So if I run the code now, let us see what is the change in the output. You get outer printed 2 times. Now how this happened, right? When outer is called, right, the control goes to this definition. outer is assigned to x, and there is this particular statement, that is the definition of inner and a print statement, right? And inner is called out in the outer function, right? When inner is called, the control goes to this particular function and it says print x. But what the Python will going to do is, it will be searching x inside the function inner. Now there is no x inside the function inner, so it will be going to the enclosing function, which is the outer function, because outer has inner inside it, right? So it is going to say, okay, I didn't find x inside the inner function, maybe I found x in my enclosing function. And who is enclosing me? Outer is enclosing me. So let me ask outer, do you have anything which is named as x? Outer says yes, and its value is x. So here also it is going to print outer, and here also it is going to print outer. So now that is your actually the the scope of the enclosing scope that you say. Now, next thing which I need to tell you is that the vice versa is not possible. So if I uncomment this x assignment and comment this outer x, and if I run the code, then you can see that you find an error that x is not defined, right? Because in this case you will be getting only one inner is printed, right? So only inner is printed once, but you didn't get this x, because this vice versa thing is not possible, right? Inner has printed x, okay, it's very fine, but when outer is going to search about x, so that the inner x will not be printed, right? So vice versa is not possible, right? So that is one thing that you need to understand. Now one more thing is that, what if I want to modify the value of this outer x inside my enclosed function, right? Inner is the enclosed function. Let me just mention that also. Now this is my enclosed function and outer is my enclosing function. Now, what if I want to modify this? Now, this we have seen in the global and the local variable also. So, what we can do actually over here is, for that particular thing, we will be using a keyword that is non-local, and say non-local x, right? So now you can see what we have done in this particular example. Let me just clear the screen and run the code so that the changes are much more visible to you. If I run the code, you can see I got inner 2 times. Now why it is? See, when I called outer, the the control goes to this outer function, assign the value outer to x, and then there is a definition of inner, right? So these are the steps. We don't go to these steps until inner is called. As soon as we come to the line number 10 and inner is called, we go to this particular statement, right? The control goes to line number 6. And it says that, okay, I have a non-local variable named x, right? And here this x will be non-local this time. So assigned this inner value to this non-local variable, which is nothing but this one. So we have assigned inner to this, we have modified the value, and we have just printed the value. So inner is printed now, and the function get complete, and now you become now you came to step number 11. At 11 you're trying to print x, and now x has been modified to inner, so you got inner 2 times printed on your screen, right? So actually that is how enclosing works. So that was a little bit information about the global and the local variable and the enclosing scope, right? And we have seen both the global keyword as well as the non-local keyword also. Now, the last thing that we are going to study in this video is something about built-ins, right? So in order to understand built-in, what I will be doing is, let's say I will be importing a module called built-ins, right? So I am just importing a module. In Python, there is a built-in module with the name built-in. So what I'm going to do is, I will be printing built-ins inside the dir function, right? And if I run this particular code, you can see a long list has been actually returned by this particular dir function, right? So a lot of things in this particular list are exceptions and errors, but here are some of the functions that we have seen. For example, we have seen frozen set in sets, right? We have seen help function, right? We have seen, example, we have seen the length method, which is len. For example, we have seen the item method when we studied about iterations. We have already worked with the range function. We know about the zip function. We know about the max and the min function, right? So there are so many things. ID, we have seen it again and so many times. We have seen tuple, we have seen type, right? So these are the list of built-in functions that are available in Python. Now, what do we understand by built-in in this particular rule, right? How this works is. Now, let me just adjust the screen and clear it first, right? And moving back over here, right? So we know that length is a function which is a variable in Python. It was in the built-in function and we have seen that just now. So let me just define my own function, right? This is my custom function with the same name as that of the built-in, right? And let me do not write anything fancy inside this code and let it be pass, right? And here you can see that we have a length function already with us, and let me just call that length function. And you know that the working of this length function is that it is going to return that particular length of the iterable that is passed through it, right? And if I print L over here, right? So you can see if I run the code, then there will be an error which says that length take 0 positional arguments, but 1 was given, right? So actually what happened over here is that we will be going to actually use the inbuilt function because they are inbuilt and we have been using them regularly. But if I define my own function and by mistake or intentionally, if I name them same as my built-in function, then after calling those functions, the exact working of those functions will not be proper. There will be a type error because length takes 0 positional argument and we have given a iterable, that is a list inside it, right? So that is the built-in scope, right? So in this particular video, we studied about the different types of scopes that we have and the rule that is actually Python follows while defining the scope of the variables, right? So the rule is local, enclosing, global, and built-in. So we have studied all the four types of scope and the rules this time. And I hope that this video is little bit informative to you guys. And for more such videos on Python, stay tuned to my channel. Thank you.